Hi, I'm Finn Peacock, and this series of short videos is going to show you exactly what's involved in a quality solar install, so you can get a feel for exactly what will happen to your house if you decide to go ahead with solar. Our lead installer, Scott, is going to show you all the details of the installation that you need to watch out for to make sure that you're getting a quality solar installation from a conscientious crew like these guys.
Here to do the solar installation. I'd like to just sort of have a look around and have a look at your switchboard and decide where we're going to put the inverter and take it from there.
This video is going to show the inverter installation, which, as you'll see, isn't necessarily an easy thing to do if you've got an old or a crowded fuse box.
Okay, well the first thing I'm looking at is to see how much space I've got in the board, because I have to put a circuit breaker and cover similar to the one that's already on here. But I believe I should be able to fit it just in there. So I've got room on the front, but now I've got to have a look at the back to make sure that I've got room there. As we can see on the back, basically in the same spot, there's a lot of cables there, so I'll have to unclip these cables, pull them out of the way, so I can get my holes in there to drill in so that I don't hit any of the cables. But you'll see as I go along the changes that I have to make. By the time I do my connection up to the board, I've got a metre and a half of AC cable maximum. Make sure it's not tight, because you need to be able to have the movement on the board still. You need to be able to follow that, right, and not go like this. Right, we've got a DC isolator we're putting on the wall here. I will be putting a circuit breaker in here shortly. It's a safety device. Basically the whole system from start to finish. You've got the panels on the roof. From the panels, sun hits those, it creates a DC power. From there, cables run around through the roof, runs down, comes through and into this circuit breaker here, or safety switch. From the safety switch it comes into the inverter. From the inverter, once it's got a certain amount of voltage, it decides it's time for it to turn itself on. It monitors what's happening out on the grid, out in the street. So basically if it sees 240 volts, that's what it pushes out, 240 volts. If it sees 0 volts, it does that as well. It's uniquely designed that way so that later on local council comes along and wants to shut down the power to do work out on the street and the grid, at least that way that they know that there's not 20 people in the local area that are all pumping power out into the street. Well, at the moment it's telling us exactly how much power we're getting from the roof. To get 2.2 in the middle winter, that's a fantastic effort. But this has what we call a knock screen. You can actually tap the screen and it'll light up the first time, and then the next time it'll go through parts of the system. Like here it's telling us at the moment this has actually done 6 kilowatts in total. The next part on it says how long it's been online for today, so it's been on for about 10 minutes now, it's been running. It's telling me the readings from the array, which is the panels on the roof, and the current that it's producing at the moment, which is quite good. Right? And then it's also telling me what's happening out in the street. There's also a sticker that tells you how to shut the unit down if you need to. And as I said, maintenance, the only thing I can suggest is middle of summer, haven't had any rain for a while. Obviously there might be a bit of a dust build up. Don't worry about any detergent, just get the hose, sprinkle it over it a little bit, wash a bit of dust off, and you're back to brand new again. I go through it with the customer and explain how it works. Yes, there will be an inspection on the work that's been done. The energy supplier will come out, whoever that may be, and they will then proceed to go through their rules and check my work off. The last test I have to do before I pack up is make sure that the unit can turn off by taking my wire back out of the board and pulling that out. You'll see that it's now got a fault and the inverter's gone offline, and that's instantaneous. From there, the last thing I do is turn my DC power off up the top. I've turned that off, and it'll just take a minute or so and that'll just fade away. It's faded already. There you go. So it's now completely turned off. And that's it. That's the last test I've got to do. Just put everything back together now and I'm finished.
Because this is quite a big house and the panels are a long way from the inverter, a big part of the job, and quite a tricky part of the job, is actually stringing the cable from the panels to the inverter.
Okay, one of the things we've had to decide on is where our cables are coming out onto the roof. Just up in the top left-hand corner, I've moved a tile out of the way, and after discussing with the rest of the team, this is where we're going to do a penetration for my cables to come out. The reason I picked that spot, it's higher in the roof, so if I've got to get inside the roof, I've possibly got more room in there to move around in, plus it's making it a shorter distance for our cable, which we try to keep the cables as short as we possibly can. Okay, what I've got here, I've got my 2 DC cables from the positive and the negative, plus I've got an earth cable that we bring up as well. What I'm doing at the moment is I'm going to start and run these in the roof. I've got a spot down along the side near the gutter in the eave, so I can use my conduit here to just slip it along and run the cable through that part. Once I get to the corner here, down the bottom here, I will have to get inside the customer's house through their manhole and run the rest of the cable around to our exit point underneath the panels. As you saw earlier, I've run the cables along the eaves on the outside in the roof there, but now I've got to go inside the roof, so I've got to bring the cable across and out for our penetration. I'm going to actually clip my cables down. I've got special clips that I clip it to the timbers inside the roof. Okay, so in I go. When we bring the cables up through the tile, we drill a hole in there. It's a 25mm hole we put in there, and then we pull the cables through it, but we put a sleeve over it of corrugated conduit, which is 25mm, so it's a fairly tight fit around it. But then we put a lot of silicone around and pat that down, and that actual penetration is actually done underneath the last panel. So one, it's got silicone around it, it's sealed off that way, and we've got a panel over the top of it. The chances of any water getting in there, we really don't have any issues with that, with water getting inside the roof around that, as long as we do the silicone and have it under the panel.
In this part of the video, we're going to show you what's involved in installing the panels on the roof.
Okay, look, we've put the brackets on the roof here. The reason we do that, obviously we've got to put railing on there and then the panels go on top of that. But with the brackets, basically what we do is we lift the tiles out of the way, we find beams, and we screw straight into the beams. We put a minimum of 2 screws in each bracket. We put 1 bracket per panel plus 1 extra. So if we've got 8 panels in a row, we'll have 9 brackets in there. There's no issues with them flying off the roof or anything like that. There's no problems with water leaking through into the roof. The brackets stick out from underneath the tiles and the water runs straight past them. Okay, look, we've picked this roof to put the panels on because of the direction where we are. We want to try and have a north-facing roof as much as possible. As you can see, the area we're at the moment, and it's early in the day, and there's no shade where we're putting them at the moment. So this is an ideal spot for us. We've got a nice angle on the roof, so we should get pretty close to maximum efficiency out of these panels where we are. The panels, we do mount them up off the roof itself. We'll get 100mm, maybe a bit more underneath, a bit of airflow. The cooler we keep those panels, they are a bit more efficient that way. Okay, the special clips that we've got mid clamps and end clamps. They're specially designed to go with this rail. There's 15 panels on this job. It's a 3.23 kilowatt system. Okay, well the panels themselves are pre-wired. They come pre-wired manufactured with clips on them, with the plugs on them, the safe, the plugs and that, and you've got a positive and a negative, and basically we run the first positive to the next negative and so on all the way along in a series, and then at the end we do our terminations underneath the final panel, and then we run the cables back to the inverter from there.
So the solar system's been installed, the panels are on the roof, the inverter's on the wall next to the fuse box, the inverter's wired into the fuse box, the inverter's wired to the panels. All that's left now is for the solar installation company to organise a level 2 electrician to come over and install a new meter, so they can actually measure what they're exporting to the grid. Once that's been done, the homeowner can switch the system on and start generating solar electricity.